So let's see on how we can be able to solve the simultaneous equations using the elimination method. As the name itself suggests, to eliminate simply means removing something. So now before we go further with elimination, I'd like you to understand about this thing. But now, how do we eliminate? So elimination is done upon adding or subtracting the two equations. That's the essence behind the elimination. Let's say we have 2x and we have, let's say, 2x. Now, when do we expect to have the combination of these two terms and how to give a cell? Now the only way we can have to do this is by subtracting the terms, hence we'll have cell. So that's how we eliminate, let's say, this particular variable x. And for instance, how about if we have this? Let's say we have negative 5y and then we have a 6y in this case. Now, when do we expect to have the combination of these two terms and how to give a cell? So now, first thing, in order to do this, we should have to make sure that the terms are the same. But now we have actually negative 5y and here we have positive 6y. So now the best way is to multiply this one with 6 and this one with 5, and such that we'll have it as, now we'll have negative 30y and I'll have positive 30y. Now when do we expect to have the combination of these two and to have it as L? So the simple way is to add, because having the addition of this will give us L, since this is negative. And how about this? Let's say we have negative 2x. Let's say we have negative 5x. So now, when do we expect to have the combination of these two terms in order to give us L? Here we have a 2, here we have 5. But we should just have to make sure that the terms are the same. So simply have to multiply this one by, let's say, 5 and this one by 2. And so that we'll have, and so that we should have it as negative 10x, and here we should also have negative 10x. Now since both are actually negatives, so the simplest way to actually eliminate x, or to have the combination of these two to give us L is to subtract, because upon having 10x minus 10x will give us L. So now that's the essence behind the elimination aspect in this case. Now let's go into the typical case and see how we can be able to actually apply the elimination method in these actual cases. Let's say we have 3x and minus, let's say, 2y is equal to, let's say, 16. Then we have 2x minus, let's say, y is equal to 6. So now, how can you be able to solve for x and as well as the y, and for these two simultaneous equations using the elimination method? So now, first thing, we should have to ensure that in both the actual equations, we should have to ensure that in both the equations the terms are arranged in the sense that they are in the same actual line. For this case, we have 3x, and here we also have 3x. We have y, that is negative 2y, and we have negative actually a y. here we have 16, and here we have a 6. So they are arranged in the sense that they are in the actually same line, and that for both equations. Now what will go up next? Then we should have to think about which term should we have to eliminate. And for instance, let's think of eliminating x first. So we should have to eliminate x. So now looking at the terms of x, we have 3x and we have 2x. Now when do we expect to have to eliminate x by having 0? So what we'll do is we'll have to multiply this equation by 2 and this equation by 3, so that we should have the similar contents here. So in that case, we'll have it as 6x and the minus 4y and I is equal to 32. Mind you, this actually 2 should multiply everything in the equation actually 1. Then we'll have 6x and the minus 3y, and which is equal to 18. That is for the equation. That is for the other equation. Then we have the similar actually terms here. We have 6x and also 6x, of which now we are safe. Now how should we have 0 here? In other words, how should we have the combination of these two and being given a 0? Well, we'll just have to subtract the two equations. So which means we'll subtract. So 6x minus 6x is given as 0. Then we'll have negative 4y, negative 3y. What would be that? So we are having negative 4y, negative 3y. So which means we have negative 4y and that plus 3y. Now in that case, we'll have it as negative y. So that will be giving us negative y, that which is equal to 32 minus 18. So what will be that? So now we'll have it as a 14. In this case, we have y being given as negative 14 because I will divide both sides by negative 1. So in this case, the value of y is given as negative 14. The next we're going to substitute into either the first equation or the second equation, and for y in order to solve for x. By the way, we need to indicate that this is equation 1 and this is equation number 2. Now we'll have to substitute into either equation 1 or 2 for y in order to solve for x. So in this case, let's substitute into equation 2. We'll have 2x minus, where there is y, we're going to put negative 14. We'll have negative 14, and which is equal to 6. We have 2x plus 14 is equal to 4. Actually, is equal to 6. Then you have 2x is equal to 6 minus 14. And I have 2x, and which is equal to 8. Now for this case, we'll have x, and being given as, we'll have it as x is equal to 4. So now we have the two values of x. Actually, now we have the two values of unknown variables, that is x as well as the y. So that's how we solve using the elimination method. And let's say we have this case. Let's say we have 2x and minus y is equal to, let's say we have 27, and we have, let's say, 2y, and that should be plus 3x is equal to, let's say, 13. Now in this case, this is equation number 1 and this is equation number 2. So now as you can see, the terms are not arranged actually in the right way. we should have to ensure that we have 2x here. Then down here we should also have the term with a similar contents, that is x. So which means we'll have 2x minus y is equal to 27, and we'll have plus x here, plus actually we'll have 3x, and we'll have 2y, that will be equal to, now we'll have 3. Then let's think of actually a term to be eliminated first. Now for this case, let's think of eliminating y first. So in this case, we're going to multiply the first equation by, let's say, 2, then the other one we should have to multiply by 1. So in this case we have it as 4x the minus 2y, and which is equal to 54. Then we also have 3x, and minus, that should be plus 2y, and which is equal to 30. So now, how should we have to eliminate actually y? Should we add the two equations or subtract? Now, since we have this is a negative and this is the positive, then we just have to simply add the two equations. So which means we'll add the two equations there. Then now we'll have 4x plus 3x, that is 7x. And that is equal, because this is that is equal to 54 plus 13. So what will be that? 54 plus 13, we'll have it as 67. So we have it as 67. In this case, it means we have 7x is equal to 67. So 7x is equal to 67. Then now we are going to divide both sides by 7. So in this case we have x is equal to, now what is should be 67 divided by 7, and of which we'll have it as a decimal number, have it as 9.57. That is the two decimal places. Now we have x, we'll just have to simply substitute into either equation to solve y. So let's think of substituting that into the first equation. In the first equation, where there is x, we're going to have to substitute 9.57. We'll have 2 times 9.57 in the minus y, which is equal to 27. So in that case, we'll have it as, what is 2 times 9.57? We have it as 19.14. 19.14, which is minus y, which is equal to 27. So now in this case, I'll just have to transfer 19.14 to the other side. Then we'll have negative y is equal to 27 minus 19.14. We have negative y is equal to, now in that case we'll have it as, that will be given as 7.86. In that case, then we divide both sides by negative 1. In this case, we'll have y is equal to negative 7.86. So that's how we make it up to, in that way. So keep that in mind. And how about if we have this? Let's say we have this case. We have, let's say, 4y, and which is equal to 7 minus x. And that should be a plus x, rather. We should have this. We should have it as plus x. And we have, let's say, and we should have it as, let's say, 4x, and which is equal to, and let's say that is negative, let's say 3y, and then minus, let's say 9. So now in this case, first thing, we should have to actually rearrange the equations in the sense that to the left hand side we should have the constant. So in this case we have it as 4y minus x, which is equal to 7. And also in this case we have it as negative 3y and plus 4x, which is equal to negative 9. So that's the typical arrangements I'm talking about. Then I should have to decide which equation, actually which variable should it be eliminated first. So let's think of eliminating x. So in this case we'll multiply the first equation by 4, then the other one by 1, because I know we'll have 4 here and also we have x here. Now have it as 16y and minus 4x, which is equal to 28. Then we'll have negative 3y and plus 4x, which is equal to negative 9. So try to actually continue that on at your own time, and also try to have the following. Let's say we have 5n minus, and that should be plus 2m, and that which is equal to 10, and that we have 3m and that plus 7n, and that which is equal to 29. So try to solve for that. And let's think of having the other case. We have 2x minus, let's say 4y is equal to 8. We have, let's say 3x and the minus 2y, and which is equal to 8. And also try that. Let's say we have this another case. Let's say we have x and we have x which is equal to 5 minus 2y, and let's say that's the case, and we have 5x and which is equal to, should be 5x plus 2y, and which is equal to 1. And let's say we have this case. Try to solve this and try to practice more. And that should be, let's say we have 3x plus, let's say 2y is equal to 13, and we have 2x plus, let's say 3y, that is equal to, let's say 12. Now try to practice those actually. Try to practice those actually equations and see how best you can have it. Thank you.